Okay. So this is thanks for joining us again today. This is the next question for Sean. Um, so Sean, the question is, um, I want you to design and implement a stack with the following functions. Ready?
Sure.
So um, it needs a push function and a pop function, and also a min function, which is essentially return the minimum, the smallest element. And these should all operate in O1 time.
Push function. What were the functions again?
Push pop
Okay.
and also minimum. So return the minimum element. The yeah.
Okay. Um. So let's see. So a stack push pop itself. It's if you put elements in, the most recent ones put in are the first ones to come out.
Mm-hmm. Yes.
So it's first in, last out,
Yep.
or rather, it's last last in, first out. Sorry,
Okay.
that's the.
Yep.
So regularly, when you want to implement a stack, hmm, you can have a you can do it with an array.
Mm-hmm.
Every time you push something in, you keep track of like a last so far
Mm-hmm.
index, and then you can just kind of, when you push it, you just decrement it. You can also do it with a linked list. So I'm going to draw that out. So you have a head. Let's say the head is here. Every time you push, you make a new element and then you append next to the last head,
Mm-hmm.
and then you make head the most recent one. So, and every time you pop head, which is a constant time,
Uh-huh.
and then you make head its next.
Okay.
So it seems like the linked list is a little bit easier to
Mm-hmm.
maintain, at least for the stack functionality. Um, Now the new function is a min,
Mm-hmm.
and you want this in constant time.
Yep.
Okay. What you can do is to keep a heap separately with all the elements pushed in. Um, on insertion, that will give you uh, to to insert into a heap would be log n time, and then but retrieval would be constant.
So can you walk me through an example?
Sure. So let's say we have the elements going this way. 1, 3. Now let's do 1, 4, 3, 2. And we're
Okay.
populating these 4 members
Mhm.
into a heap. So, well, we first started with nothing. The root of the heap is nothing. When we populate 1, we just put 1 because we don't see anything. When we put 4, we, since a heap is a binary tree, we throw 4, I guess, in the first null that we see, if both of them are null. We also want to make sure that the heap is as balanced as it can be, so when we throw in the 3, it's here. And then when we go to the 2, we look at which one is the bigger one, and then we swap it with that. So when 2 is looking at 1, it says 1 is already smaller, so let me grab the biggest so far out of my children, which is 4. So 2 compared to 4, 2 is bigger. I mean, sorry, 2 is smaller than 4. So we swap the 4 and the 2, so this will become a 2. And then we make 4 its children.
But the so what's the runtime for that if you for push and pop in this case?
So for insertion, it's n log n.
Hmm.
If you pop, it's constant. So when you pop, you take the
Hmm.
head. The head will always be the smallest. What you do after you pop the head is you um, take the next biggest or the next smallest one out of its children. So you take the 2. When you
Okay, so Sean, I'm gonna well, so
go ahead.
I think you misunderstood the question actually. So all operations have to be in O1 time.
Oh,
Push and pop.
including.
Yeah.
Okay,
Push and pop. Yeah.
got it. Okay, so this is an invalid
Yeah.
solution.
Instead, so you started with this. I mean, you implemented a general stack, right?
Right.
Can you think of any ways to use that as well to well, the general stack? What's the runtime for the general stack for push and pop?
Uh, 1.
Yes. And can you use the stack to implement min as well? Can
Min.
you use
Okay.
yeah.
So, just to walk through some examples, if I pop 1, 3, if I push these members into a stack, my min will point to 1. And if I pop the min just literally reads you, right? It does not pop or
No,
in conjunction.
it
Okay.
tells you
It
what
just
the
tells you what it is.
smallest element is.
Okay.
So
Hmm.
why don't you walk me through uh walk me through an example. So for each after you push something, tell me what the min is.
Oh, I see. Okay. Yeah. So I'll start. I'll change this example a little bit. So the min's in the middle. I'll just do
Yeah.
2, 3, and let me erase this. So let's say we're pushing these members.
Mhm.
We do 5. So we can keep an auxiliary that is like, just say stack, whoops,
Yep.
stack min, a integer if we're pushing integers. Um, so I guess we can, you know, keep it 0 so far. While we pushed our first member, if there's nothing in the stack, um, let me push it from the bottom. It's probably a little bit better. So we push 5. There's nothing so far, so we just assign that for the first case. If we push 4, 4 is less than 5, so
Yep.
you can see that. If you push 1, 1, and when you push 2 and 3, it'll see that 1 is less than 2 or 3, so it doesn't do anything once we do that.
Okay.
There's a case where you
Now
pop,
I want you to pop.
yeah, there's a case where you pop the minimum.
So what happens when you pop 3?
When you pop 3,
What is the min?
the min is still 1, so as
Okay.
long as what you pop is greater than the min, you don't care.
Mhm.
Um, so let's
So let's.
say we pop 3 and then we pop 2.
Yep.
Now we have 1. When we
So
go ahead.
no, I
Uh,
think yeah.
okay, so when we pop 1, we know the
What's
min
the min?
should no longer be 1, should be 4
Hmm.
in the stack. So let's see. 4. One way you could do it is iterate through the rest of your stack to find the min, but pop
Oh,
would be a linear operation if that's the case.
could you do it with? Could you do min? Or sorry, could you do all of them in O1 if you use additional storage?
Yep. Yes. Okay. Yes, I think I can. Okay. One thing we could do is keep a separate stack, so another
Hmm.
linked list that just stores min so far.
Hmm.
So let's say we're populating these same numbers.
Yep.
If you put 5, the min is 5.
Mhm.
If you put 4, the min is 4. Put 1, min is 1. But 2 and 3 still retains 1. So whenever you pop one, you pop the other. And that will tell you the min that's still there. So once we pop one, this one, we pop this one. Head will be pointing to these, and we know that the min is 4 here.
Yep, that's pretty good. But can you optimize that even further? So
Okay.
because you're storing one multiple times, could you optimize that further?
Yeah, yeah. Um, we can chop off these duplicate ones. And instead of popping each time, we compare to see if that value equals this value. That's one way to do it.
Yep.
So essentially, we save all the greater than min's value. Um, Let me think of other ways to do it. I think, I think for this case, you
Mhm.
probably can't go any faster or be more efficient because you need these ints
Yep,
because they're
that's right.
all
I
mints.
just wanted you to see whether you could avoid storing the extra numbers.
Mm.
But yep, so you got it.
Okay, so
Now,
should I implement?
yep.
Alright. Is it here? Here we go.
And I think to make it easier, uh, you don't have to. Let's assume you have access to a class called stack.
Okay.
So the stack implements push and pop only.
Yep. Oh, I see. So,
Yep.
okay.
So you don't have to implement the stack itself using a linked list.
Okay.
You already have stack with push and pop.
Got it. Change some settings. I'm just gonna use tab size too. I've given up.
Sure.
Let's do public class stack with min. So we will need 2 stacks. Well, yeah, 2 stacks. One for the just the regular stack functionality here,
Mm-hmm.
and one for the min tracking stack. So let me write that down. Stack. Let's do. Trying to find a clearer way. Just normal. Normal stack. And now we have stack min stack. So the min stack will track the minimum so far.
Yep.
I have functions push.
Mm-hmm.
Let's say it takes an int. Let's just do int for now. I can change this.
Yeah, that's fine.
Int I have a pop that returns an int. And then I have a int min. Alright. So I'm gonna go through this I'm gonna go through this in passes. One just simply putting this the normal stack functionality. So normal stack dot push, I believe it's lowercase, push I, pop normal. Let's do int pop int equal normal stack dot pop, and I'll do something with that later. Minimum we don't need to touch right now. Okay, so for push, if just do equals new stack, initialize the stacks. If min stack is if it's empty, this is our initial case. We want to populate it. Min stack dot push. Just populate that. Else, if it's not empty, we need to compare it with here. Yeah, we need another integer that keeps track. Last min int.
Do you?
We can peek actually. Yeah, we don't need it. else. Um, let's do else if
Oh,
min.
I guess. Um, so you should remember that the stack class also has a method called peek.
Yep, yep, yeah. That's what I was doing. Peak is if I is less than peak, which is the top head, then min stack dot push. I guess I can turn this into it's like an or something here. Um, with that, I think that would throw an error because this will be a no. If there's nothing in my min stack, I'm not sure what peak would do, so I'll just do that for now.
Okay, that's fine.
So I think push is okay. I will check in a bit. So when I pop my regular int if min stack dot peak pook equals popped int, then you pop um, min stack dot pop, and for this you just peek return min stack dot peak. And I think that wraps it up for now, but I'll double check.
Okay, hold on.
Oh, I didn't return anything. Return pop
Yeah,
int.
that makes sense.
So, so when I put push 5,
Mhm.
I have two stacks with nothing. Push int equals 5, normal stack push.
Mhm.
Min stack is empty, so min stack will also push. And that's it. I push 4, um, normal stack will be pushed. Min stack is not empty, so I is, which is 4, is less than min stack dot peak, which is 5.
Mhm.
So that'll push that, which is this case. Um, when we push 1, the same thing will happen. When we push 2, min stack is not empty. 2 is not less than 1, so it will not get pushed into the stack. And same with the 3. So say if we popped, um, you will get 3, which is the pop int. Min stack peak would be 1, which is not 3.
Mhm.
So you will just return 3. And if you call min, then it will still be 1. Let's say we've popped all the way down to 1. Pop will be 1. Peak will equal to be 1. Popped int will also be 1. So it will pop this element and return 1. So when you look at minstack.peak, this will be 4.
That's good. But what if I said that the stack, so the elements aren't unique? They don't have to be unique.
If the elements
So you could
are
have
not unique.
5, 4, 1, 1, 2, 3.
Okay. Yeah, that's a question I should have asked in the beginning. Um, what you could do is do a key value pair for each one.
So actually, I'm gonna say that it's much simpler than that.
Yeah, yeah. Mm, oh, okay. If you see a when you push, if I is equal to stack peak,
Mhm.
you also push. So
Yeah.
I would put an equal sign
Yes.
here.
Yes.
Okay. All right.
Okay.
um. Yep. I think that wraps it up on my end.
Yeah. So let's see. So that was 25 minutes.
Okay.
Okay. So you're within the time limit.
Cool.
Um. So in the actually in push,
Mhm.
uh, you said that those conditions, like, it would probably throw an error, but I don't think it will. Like
Okay.
in Yeah. So if say min stack dot empty was true, then, well, you would know it's empty, right? And then if it's not true,
Oh,
then
right.
it'll go to the next condition.
Oh,
So
so you
actually,
mean
you
you
could have,
mean this, right?
yeah, that would have been fine.
Got it. Yeah, I think you're right. Yeah.
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 And I think everything checks out. Um, so a few things I observed were, so I think you could have used a better example at first.
Yep.
Uh, this wasn't just the um, non-unique numbers, but it was actually no, numbers in general, I think.
Yeah. Yep.
But you could have asked me more questions to define the problem as well.
Yeah.
So also, I think um, it's easy to, like, once you do a lot of these problems, it's easy to uh, stop questioning, like, or stop asking questions, because you sort of know where the interviewer is going with this.
Mhm.
But
Mhm.
it's important to uh, like, actually say that you're going to assume a certain something. So when you set the items being pushed to int, like, I actually, I don't think, did you just said, okay, I'm going to push an int, right? But like, then
Yeah.
I
Yep.
think it's good to tell the interviewer, uh, actually say, okay, I'm going to assume, like, we're working with integers here, and yeah,
Okay.
because that way they can correct you if not,
Yep.
right? Even if you don't ask them.
Yeah.
And yeah, I think that's about it.
Okay. All right. Um. So you want to close it out?
Sure. Yeah. Oh, I guess some more things you could have asked
Mhm.
were like, what am I supposed to do when, if the stack is empty, and, like, you know
Uh
stuff
huh.
like
Uh
that,
huh.
edge cases. But that's fine.
Okay. So yeah.
We're good.
Yep. Yeah, we're good.
All right.
Yeah.
So,
So thanks for joining us for this
all right.
session.
Thanks for joining us, everyone.
All right. We'll get to the next session soon.